Good morning, students. This video is for the chapter 5B of class 10 physics ICSE. Here we will know about lens and the terms related to lens. First of all, we will know about the spherical refracting surfaces. We have learnt about the refraction, okay, and we have learned that how the light ray refracted from a plane surface, and this is the plane surface. This is like a plane of table, you can consider, okay. The plane of table is like a plane surface. Above there is a air medium, and below the surface this is the glass medium. So whenever light ray incident like this, it is bent toward the normal. You know that the simple refraction. Now for in this figure, see, in this figure we have a surface which is not plane, okay. So this surface is a spherical surface, like a section of ball, okay. You can consider a section of ball, or you may consider the spoon, okay. Suppose the spoon is taken inverted, so then this one is the bottom part of the spoon. When it is taken inverted, you can see it is above. So the this surface, that means inside the ball, suppose you consider this one is a ball, so inside the ball it is glass, and outside the ball it is air. Now suppose that light ray incident here. So whenever light ray incident from air to glass, what you find that uh, most of the section, the middle section is closer to you. Suppose that you are standing here, okay, you are standing here, so this middle section is closer to you, and uh, these edges are far from you, okay na. These edges are, suppose this is you, okay. So this section, this part, that means the back side of the spoon, is called the convex surface. Now sometimes the light ray may incident from this glass medium, that means from inside the ball, and it will go outside, emerges to air. So at that time it will reflect on a surface which is the spoon, okay, the spoon where we kept something, the part of the spoon where we kept something. Suppose water is taken on a spoon, the part where water is stay, I'm talking about that part, and that part is considered as this section, and this is called the concave surface, okay. Suppose that you are standing here, then what you found, that the middle section is not nearer than the edges, that means the edges are nearer than the middle section. So this is called the concave refracting surface. So we have two types of refracting surface, one is convex, another is concave. Now see this, we have learnt about the refraction through a rectangular glass slab. We know that when the same kind of situation happened, like when light ray incident from P to Q on a surface of glass, then there is a two refraction on the two surfaces of the glass, when the light ray entering from air to glass, and when the light ray leaving from glass to air. So finally what we found, that the incident ray, the direction of incident ray and the emergent ray are parallel to one another. That's what we have discussed in the previous chapters, okay. So one more thing that we have discussed, the principle of reversibility, that is whenever light ray reverse, it is from S to R, then R to Q, then Q to P. This is called the principle of reversibility. That means light may take the same path to back, okay, and the same path it will take to emerges out. That means it will take the same path to back, okay, simple. You know about the principle of reversibility. Now we are taking here a sphere, a spherical ball, suppose that a spherical glass ball, inside which the light rays are passes refracted, okay. See, first of all, the light ray is incident from A1 to B1, it is incident normally here, okay, and it is go toward the center of the spherical ball, spherical glass ball, and then it will go to the point B1 and then passes to A1. So here the light ray incident normally, so that's why there is no any deviation, okay, it passes like the same line, on the same line. But if we incident another line PQ, by taking that PQ is parallel to that line which is incident normally first, okay. So it is incident here on PQ, and if you draw the normal on Q, then we'll find the normal always passes through the center. Remember that, you may have learned in circles, and it is now a sphere, but whenever we draw is normal on any point on the surface of the sphere, then it is always passes to the center. So that's why whenever the normal is draw, you know the refraction, that it go toward the, it bend toward the normal first when it is entering from air, that is rarer, to this glass, that is denser. So it go bend toward the normal, and here it is incident once again. So one more refraction is occurred here, and the normal is drawn, so it is from air to glass na, so that's why it go away from the normal. So the overall, you will find that this is the direction of incident ray PE, and this is the direction of emergent ray RS. Okay, so there is a deviation. The light ray deviate. The light ray always deviate here when it is passes through a spherical ball. So based on this, we will take the types of lens as a, see, the lens. What is lens? This spherical ball is also considered as a lens. Okay, so first see the definition of lens. Lens is a transparent medium body enclosed by two surfaces such that at least one of the surfaces is spherical surface. So see, inside this is glass. Okay, this is glass. These are the lenses, and those are enclosed by two surfaces, and out of those two surfaces, maybe those two surfaces are spherical surfaces. Like here we have bioconvex lens, that means both the surfaces are convex. This one is plano convex lens, that means one of the surface is convex and the other surface is plane. So this one is called plano convex lens. Here we have one surface as convex and the other surface is concave, so this one is called concave convex lens. The same thing is for the concave lens also. Here we have the concave lens. See, two concave surfaces are there, so this one is biconcave lens. This one is plano concave lens with one plane surface and one concave surface, and this one is convexo concave with one concave surface and one convex surface and one concave surface. This these are the types of lens. Now we'll know about the refraction of light through a lens. Okay, refraction of light through a lens. You know, in the previous page we have refracted a light ray from a spherical ball. So see this, you can easily understand the refraction through this part. Here this one is a biconvex lens, that means two of the size surfaces of the lens is convex. So light ray incident here at the point B, and the normal is drawn, and it is finally refracted toward D. So the emergent ray is towards C, D. So there is a deviation. This one is the incident ray and this one is the emergent ray. Now if we break this convex lens into smaller pieces, then it may be represented as the set of prism. You can see, okay, for these two parts we can consider a prism taken at the top. This middle section is taken as the rectangular glass slab, see, and this one is, these two are taken as this part, okay, the inverted prism. So it will be better to understand that whenever light ray passes through a prism, that then after reflection, where the light goes, light ray emerges out. You know that we have learnt about prism. Okay, so you know that whenever light ray incident on a prism, it always refracted toward the base of the prism. See, here at the bottom we have an inverted prism, so light ray incident here, it will deviate toward the base of the prism, and on the middle it is a rectangular glass slab, so light ray will pass, when it is incident normally, it will pass undeviatedly. So there is a point where those three lines meet, those three emergent rays meet, and this point is named as F. Okay, now see, this is the concave lens. Okay, again you can see the light ray incident here, but now when the normal is drawn, it will bend toward the normal and it is go away from the lens, and when it is leaving the lens, when it is leaving the glass medium, then again see, this is the normal, so it will go away from the normal. Here it is bent toward the normal and here it is go away from the normal, but so finally what we say, that the incident ray is like that and the emergent ray is like that, so it is leaving, it is go away from the lens, body of lens, go away from the body of lens. Again, if we break this concave lens into a smaller section, then we found that two prisms, one at the top there is an inverted prism, and at the bottom the prism is taken erect, okay, erected prism. At the middle section the rectangular glass slab is taken. Now if we incident the light rays, you know that light ray will, whenever it is incident on a prism, then it will deviate toward the base of the prism, and here it is also incident on the prism, it will be deviate toward the base of the prism. And light ray incident at the center, normally on the rectangular glass slab, so it will passes undeviatedly. So those two light ray will never meet, okay, and we know that whenever those never meet, then we draw a dotted line back to the ray, okay, and try to try to uh, try to meet them at a point. So we found that those meet at a point on the on the on the incident ray that incident normally, okay, from B at the point F. So here those are meet at a point called F. So the basic action when the refraction occur through a lens, that the concave lens, convex lens converges the light rays. So those light rays converges at a point F, and here in concave lens the light rays incident and those diverges, those go away from the lens. Suppose that they are appearing from a common point, okay, they are go away, they are diverges from the lens, and they are, those rays are appears to be coming from a common point F, and this point is called F, okay. So that's why this convex lens is called convergent lens, okay, convergent lens we can call, converging lens we can call, and this concave lens, this concave lens we can call this concave lens as diverging lens, okay. Now see this, the terms of the lens. So how we can make a lens? First see, those are the two spheres with the center C1 C2 and radius R1 R2, two spherical balls are those, okay. Suppose that we cut a part like this was one section taken as one surface, and this one is another part is cut out, this one is second section, those are cut from a spherical ball, remember that. Now those two parts are joined, see this part is one part, the first is surface and this one is the second surface. So when those are joined, so this one become a lens, okay, this one become a lens, and this is because those balls are of glass, so this lens is also of glass, okay, same kind of material. Now for this surface, this one is the second surface now, so for this surface C2 is the center, okay, C2 is the center, and for this surface which is one surface, first surface, C1 is the center, C1 is the center with the radius R1. So this is the lens that we called convex lens, okay, and those points, see I will tell about those points. First we see about concave lens. So concave lens we can prepare, suppose that we have a, this one is a cylinder, okay, this one is a cylinder, and we cut a spherical size, that means a spherical part of the cylinder from the cylinder, and here also another spherical part we cut from the cylinder. So at the middle of the cylinder this section is left, okay, see this section is left. So if this section is left, this section is act as a concave lens with this surface. See there are two spherical refracting surface, this one is one of the surface, it is taken as the first surface, and that's why this one is with center C1. See this one I am talking about this surface, so this is the center C1 with the radius R1 for this circle, okay, this sphere. Now this part, this surface is called the second surface of the lens, okay, and it is because of this sphere, and the center of the sphere is C2, so this one is the C2 center of this surface, this spherical surface. This one is the second spherical surface with the radius R2. So this one is the concave lens, this one we form a concave lens. Now see the terms of this lens. Center of curvature, those C1 and C2 are called center of curvature, those are actually the center of the assumed sphere of the lens. See this one is the lens, now we have this lens only, so if you assume a sphere then we will have a center, and this center is for the first surface, and this center is called the center of curvature for one of the surface. Suppose that we are talking about C2, then this one is the surface, if we assume a sphere then there will be a center, and this center is called center of curvature. So there are two center of curvature, okay, for a lens. Again for the concave lens we will have the same thing, this one is a part of sphere, so for this sphere this one is the center C1, this one is the center C2 for the second surface, okay. So in this way we can say that we have two centers of curvature for a lens. This center of curvature is the center of the assumed sphere of the surfaces of a lens. Now radius of curvature, again we will say the same thing, the radius of curvature is the radius of the assumed sphere of the of a surface, of one of the surface of the lens, maybe it is concave or convex, okay. Now see what is radius of curvature. See, I repeat it once again. Suppose this one is a surface of lens, and we are supposing a sphere designed on the surface. Then for this sphere, whatever the radius is called the radius of curvature for this surface of the lens. Okay, so there are two surfaces, so there of a lens, there are two surfaces, so there are two radius of curvature. Now see the principal axis. What is principal axis? The principal axis is the line joining the two centers of the two surfaces. Okay, there are two surfaces, and for the two surfaces we have two centers. So see this one, this line joining the two centers, dotted line, is called the principal axis. Now see this. Now we have the optical center. So what is optical center? This is a lens. Okay, this is a convex lens, and we are supposing a point here on the principal axis O. Okay, exactly middle on the lens, maybe exactly middle or maybe somewhere else, but the point O is inside the lens on the principal axis, that is the line joining the center of curvature C1 and C2. Okay, now see, as the light ray incident, it is directed to that point that we have considered as O. Okay, and there is a refraction on, there is two refraction on the two surfaces of the lens. You can see this one is the first refraction, this one is the second refraction. Then what we found that the direction of the incident ray, which is toward the point that we have considered, toward the point O, and the emergent ray, those are parallel to one another. That means there is no any change in direction of the ray. The same thing we can consider for this lens also. Okay, see, for this lens also we have the same thing. Okay, this is a concave lens, but see, there is a lateral shift. That means the direction of incident ray is like that. Okay, toward this, and this one is the emergent ray, so there is a lateral shift. There is a gap in between those two rays. Here also we have the same gap. Okay, this one is called lateral shift. But suppose that if we consider the lens is very thin, okay, the lens is very thin, then this shift may be ignored, can be ignored. That means that for a thick lens, there will be a visible shift. Okay, visible lateral shift. But for a very thin lens, there is no any lateral shift. Maybe there is a lateral shift, but it is too much small, that can be ignored. So we can consider that the light rays passes from the optical center and it emerges out on the same line. Okay, see this one, for this lens also we are taking that the light ray coming incident and passes through the optical center O and emerges out on the same line as the same line. So we can define the optical center like that. It is the point on the principal axis. If the light ray is directed toward this point, then it emerges without deviate. Okay, without any deviation. Now this term, principal foci and focal length. Okay, so see first, suppose that we have a point here F. Okay, and we are incidenting the light rays from this point F on the lens, and we found that the refracted rays are parallel to the principal axis. Then this point is called the first focal point of this convex lens. Okay, now for this lens, for this concave lens, the light rays are incidenting on the concave lens. It is concave. Okay, na, light rays are incidenting on the concave lens, and those are directed to a point on the principal axis. Those are actually directed toward to a point F1 on the principal axis. Okay, but because of this presence of lens, the refraction occur here. Okay, and that's why those two light rays are refracted, but now they are refracted parallel to the principal axis. So this point to which the rays are directed. Okay, but those ray will not meet at that point because of the presence of this lens. Okay, and that point is called the first focal point of this concave lens. Okay, now what about the focal length, first focal length? Okay, see, we know about optical center. So from the optical center, whatever the distance of this first focal point is called the first focal length. It is represented with small f, f1. Okay, so the distance of the first focal point from the optical center. From the optical center is called the first focal length. Remember that. Now for the second focal length, we will say the same thing, but see, not the same. Here we are incidenting the light rays parallel to the principal axis. Okay, and the light rays are refracted after the lens, and those will meet at a point. See, first we have, whenever we are reading about, whenever we are on the page of the lens as a prism, set of prism, then we have told that, I mean we have discussed that there is a point f. Okay, so this is the point f that we are considering at that time. That means the point where the light rays will meet after refracted through a lens. So this is for the concave lens, convex lens it is. Okay, so this one is called the second focal point. How will you define the second focal point? That like whenever the light ray incident parallel to the principal axis on a lens, then those light ray will refracted toward a point and meet at a point on the principal axis, and that point is called the second focal point for a convex lens. Now for a concave lens, the light rays will incident parallel to the principal axis on a concave lens. Okay, and as you know, the rays are diverged. Okay, but the rays are diverged in such a way that those are appearing from a common point on the principal axis. Okay, and that point is called the second focal point for the concave lens. Okay, second focal point. Now what is the second focal length? So the distance from the optical center to the second focal point is called the second focal length. It is represented with letter small f2. Okay, now see what is focal plane. See here from the picture, first see the definition of focal plane. Focal plane is the plane normal to the principal axis on the focal point f1 or f2. Okay, suppose if we take a normal plane, that means if we take a plane, that plane passes through the focal point. Okay, and it is perpendicular to the normal to the principal axis, then this plane is called the focal plane. There are two focal points, so that's why there are two focal planes for a lens. The first focal point, for the first focal plane, the plane which is passes from the first focal point is called the first focal plane, and the second focal plane you know about. Okay, which is passes from the second focal point. Now see those figures. Here light rays are incident obliquely. Okay, parallel beam of light. Okay, all the light rays are parallel and those are incident obliquely on a lens. Then after refraction, those will meet at a point. Okay, at a common point. But remember that the common point, the point where those meet, must be on the focal plane. That means whenever the refraction occurs, the point will definitely on the focal plane. Okay, the plane which is perpendicular to the principal axis at the focal point. Now here also, suppose that obliquely the parallel light rays are incident on a concave lens. Then what happened? The light rays will diverge. Okay, see, this shows the divergence of light rays. Okay, so all those rays are appeared to be coming from a common point. Okay, those rays are appeared to be coming from a common point, and that common point is definitely is on the focal plane. Okay, is on the focal plane of the concave lens. So this is complete for the class. So the chapter 5A is completed.